Our objective for today, I can write, identify, and graph parallel and perpendicular parallel and perpendicular linear equations. I can write, identify, and graph parallel and perpendicular linear equations. Read together, 1, 2, 3. I can write, identify, and graph parallel and perpendicular linear equations. Read again, 1, 2, 3. Read it again, 1, 2, 3. Okay, Luis, can you read it for us, please? Thank you. So our objective for today, we're going to be looking at still linear equations. We already know what they are, but today we're looking at two particular ones, parallel and perpendicular. Okay? Write that down and give you some time. So once again, we don't need a Fourier model, since we already know what linear equations are. We don't need, we do need steps, sorry. Only 5 steps. Copy these down, please. Only 5. It says, step 1, solve for y and write the equation slope-intercept form. Step 2, compare the slopes and intercepts and identify if the lines are parallel or perpendicular. Step 3, identify and plot the y-intercept. Step 4, identify and use the slope to plot points. Step 5, graph your lines. 5 easy steps. Solve for y and write the equation slope-intercept form. Step 2, compare the slopes and intercepts and identify if the lines are parallel or perpendicular. Step 3, identify and plot the y-intercept. Identify and use the slope to plot points. Graph your lines. Copy that, please. All right, before anything else, let's clarify what parallel and perpendicular lines are. So check this out. According to the definition that our textbook gives us, look up, please. Don't write this down. Look up. Parallel lines are lines in the same plane that have no points in common and will never intersect. This is the example that they give us. Perpendicular lines are lines that intersect to form right angles. And this is the example they give us. So now, why did I ask you not to copy that? Because I want us to come up with our own definition. So here we go. Start with parallel lines. First of all, earlier, some of you said that parallel lines never intersect. Is that correct? So I think we can keep that part. Good. However, we won't keep everything else. All right, so never intersect. So parallel lines never intersect, comma. Now that we see from the graph, they never intersect. Now let's look at the equations themselves. Who can help us out from the equations to get part of the definition? Jose. They have the same slope, comma, and what else? Look at the equations. What else do you notice on the equations? Hold on. Brian. And different y-intercept. Let's see if it's true. Looking at the graphs, do they intersect? No, they will never intersect. But why? According to the equations, because they have the same slope and different what? Y-intercept. So copy this down on your notes. Parallel lines never intersect, and they have the same slope, different y-intercept. Copy that, please. All right. Now that we have the parallel lines, does that make sense? That definition we wrote down? Yeah, never intersect. They have the same slope and different y-intercept. Okay. Let's go to perpendicular lines. Perpendicular lines. What is obvious here? That it makes a what? 90 degree angle or right angle. So the one thing we are going to use from here is form right angles. Okay, we got that down. Perpendicular lines form right angles, comma. Now, we looked at the graph. That's where we got from the graph. Now, look at the equations. Talk over your neighbor and see what would be the next thing you would write. Look at the equations. What was the next thing that you would write for your definition? Okay, who can elaborate on the next part? Go ahead, Joseph. They do, but they have something in particular, those slopes. Manny, the slopes are what's the other word? The slopes are, what are they? Reciprocal inverses, comma, and okay, let's see. They form 90-degree angles, yes. The slopes are reciprocal inverses. The reciprocal of 2/3 is 3/2. The inverse of a negative is a positive. Okay, so far so good. What else? Luis. They have different y-intercepts. However, before you write anything else, look up. What if I did this? Right now, the y-intercept on this one is 1, 2, 3. It's 3, right? The y-intercept for this one is 1, 2, -2. So, what if I move this line there? What do you notice? They cross what? They both have the same y-intercept. So does it matter if they have the same or different y-intercept? No. So therefore, what would we write? Perpendicular lines form right angles. The slopes are reciprocal. And what else do we write at the end to clarify or to just elaborate on the y-intercepts? And yeah. Bam. The y-intercepts may or may not be the same. That is correct. Bam. Emilia in the house. 10Q in the house. House. How's infinity? May or may not be the same. All right? Copy that, please. All right. We got this? All right, example number 1. Copy this, please. Example 1. You're going to write, example 1, identify which lines are parallel. Identify which lines are parallel. Identify which lines are parallel. Write this equation down. Y equals 5/3 x minus 2. Semicolon, punto y coma. Second equation, y equals x. Semicolon, punto y coma. Y equals 5/3 x plus 4. Semicolon, punto y coma. And the last one is y equals x plus 1. That's colon. Because you're only doing one dot. All right. So, all right. According to the steps that we wrote, we said make sure we solve for y. Are all these equations solved for y? Yes. Are they in slope-intercept form? Slope-intercept, 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 slope-intercept. Yes, they all are. So, next, step 3 says identify the slope and the y-intercept and tell whether they're parallel or perpendicular. Let's see. Right now they're asking us to find the parallels. Focus, please. What's the slope on this one? 5/3. Is there another one that has the same slope? So to be parallel, they need to have the same slope, but different what? Do they have different y-intercept? Yes, so this is what we're going to write. Y equals 5/3 x minus 2 is parallel to y equals 5/3 x plus 4. And you're writing that down, right? Daphne, and you're writing that down? Next, let's look at the other one. Look at the next equation. What is the slope of this equation? 1/1. Is there another one that has 1/1? Yes, this one. What is the y-intercept on this one? Does this one have a y-intercept? So it would be what? Plus 0. And what is the y-intercept on this one? 1. So are these two parallel? Yes, so you would write y equals x is parallel to y equals x plus 1. And we're done. You don't get it. They're asking, identify which lines are parallel. So what two lines are parallel? Brian? Well, what does parallel lines mean? That they have the same what? Very good. Same slope, different y-intercept. So let me ask you a question. Look up. Write this down. Example Q. Y equals 3x minus 2 is parallel to what? Give me an equation that's parallel to that one. Right, you write it on your paper. Write on your paper an equation that's parallel to that one. Go. Let's see, Gael. What's your what equation is parallel to that one? 3x plus 4. Hands, have you got that? Or do you agree with that? Yeah. Why? Because they have the same slope, different intercept. Everybody understand? Okay. Let's do one more. Example super duper Q. Y equals 1/5 x plus 3. That one is parallel to which? Find me an equation that's parallel to that one. Okay. What line is parallel to that one, James? -3 or -2? Hands if you agree that that's parallel to that one. Yes, because they have the same what? Slope and different y-intercept. Everyone understand? Okay. Write this down. Example, mega q. Right. Write two lines that are perpendicular to one another. Okay? So I'm going to start you off. Here we go. Y equals 2/3 x plus 5. Now check this out. This is a symbol of perpendicular. Look up. Y equals 2/3 x plus 5 is perpendicular. Yeah, an inverse t, yes, because it forms a what? Right angle, okay? So, a line that's perpendicular to that one, check this out, is y equals -3/2 x minus or plus 1. Okay, turn to your neighbor, let them know why this one is perpendicular to that one. Reciprocal inverse. No. Huh? Example, Power Ranger Q. Write this down, please. Same instructions, but write this down. Y equals -5x plus 3 is perpendicular to another. So find me the equation perpendicular to that one. Write it down, please. Copy that. Okay, Jonathan, what'd you get? Y equals 5x minus 3. Hands if you agree with that. Nope, that is incorrect. Who can fix it? Fix this one that they gave us. Go ahead, Anissa. 1/5x minus 3. Hands if you agree that this is perpendicular to that one. That is correct. So what needs to be true? That the slopes are reciprocal inverse. So what is the reciprocal of 5? 1/5. What is the inverse of a negative? Positive, and the y-intercept doesn't matter. One last one of these. Example, Shazam Q. Yes, it is. Y equals -6/7x minus 4 is perpendicular. And write your equation, please. Go. Copy that. Okay, let's see what we got. Azul, what was yours? Y equals 7/6x plus 4. Hands if you agree with that. This is correct. Yes. All right. So, check this out. Next one. Copy this one, please. Example number 2 says y equals 2x minus 3. That's one of them. y equals negative 2x, no, negative 2/3 x plus 3. 2x plus 3y equals 8. And y plus 1 equals 3 parentheses x minus 3. They want us to find parallel lines. So let's think back again. Step 1, they need to be solved for y. Are they all solved for y? No. This one, yes, yes, and they're both in slope-intercept form. How about this one? No. Line down the equal sign. What do I need to do? Subtract 2x, subtract 2x. We're left with 3y equals negative 2x plus 8. What's our last step? Divide by 3, divide by 3. Y equals negative 2/3 x plus 2.6 bar. Hold on, before you leave, look at this one. Is this one solved for y? No. So, before we bring this one over, I'll wait. Before we bring this one over, we need to distribute the 3. So we end up with y plus 1 equals 3x minus 9. And then minus 1 minus 1, y equals 3x minus 10. So by looking at them, which one of these have the same slope? Which one? Of course, this one and this one. Do they have the different y-intercept? Yes, so these two are the ones that are parallel. All right, so your home plate for tonight is found on pages what? 553 and 554. Have a good one, everyone. Your home plate. See you guys tomorrow. Bye.